My name is Dr. Esther Trufan, and in this video, I'm going to demonstrate how to determine the solubility of ionic compounds in water. For this experiment, we're going to need some equipment. I will be using 3 150 milliliter beakers. I will use 3 spatulas, but you may use just one and clean and dry in between measurements. I will also use 3 stirring rods. You may use just one and clean and dry in between experiments. We'll need a scale, 3 weighing boats, and this is optional, you may use a laser pointer. As far as our chemicals are concerned, the only one that you must have is deionized water. And that's here, because we are determining the solubility of ionic compounds in deionized water, so this is the most important thing. The second important thing is to find a collection of chemicals that are sharing either the same cation or the same anion. Let me demonstrate. We may choose sulfates. And if we want to study the solubility of sulfates, we may want to pick magnesium sulfate, calcium sulfate, and sodium sulfate. And that would give us at least 3 compounds through which we can estimate a general pattern for those materials. Additionally, here we have a whole bunch of other white salts. We could pick something like a magnesium chloride and a magnesium sulfate. This would give us a sense of the solubility of magnesium-containing salts. Or we could look at sodium chloride, sodium sulfate, and sodium carbonate, and this could allow us to draw some conclusions on the solubility of sodium salts. We could pick some chlorides, sodium chloride, calcium chloride, and magnesium chloride, and now we can draw conclusions about the solubility of chlorides. In General Chemistry 1, we talk about solubility in absolute terms. Is a material soluble or insoluble? And the rule by which we determine those is 100 milliliters of water or 100 grams of water able to dissolve at least 1 gram of the solid? If it is, we call it soluble. If it isn't, we call it insoluble. And that brings us to the last piece of equipment that we need, a 100 milliliter graduated cylinder. So let's get started. The first thing that we're going to do is measure out 100 milliliters of deionized water into 3 150 milliliter beakers. For this measurement, it is really important that we get as close as possible to the 100.0 milliliters. And in our first measurement, we have 99.9 milliliters of water. We transfer this into our first beaker. Then we repeat. For our second measurement, we are exactly at the 100.0 milliliter mark. And for our third measurement, we are at 99.8 milliliters. With this, we're done with the water. Next, we select our chemicals that we want to work with. And for this experiment, I am going to work with the chlorides. I have sodium chloride, calcium chloride, and magnesium chloride. Of each of these chemicals, I will measure exactly 1 gram in individual weighing boats. So I will turn on my scale, place a weighing boat on top, tare it, select my first chemical, that is sodium chloride, and I will measure 1.00 gram of this. I have exactly 1.00 grams. I will leave it next to my first cup, and I will transfer it in there. And then I can set my weighing boat to the side. Next, I'm going to place another weighing boat, tare it, take my second chemical, which is calcium chloride. I will measure out as close as possible to 1.00 grams. It is a little bit more than that. It is 1.004. We don't want to exceed the 1.00 grams, so any excess we're going to remove and discard in a waste container. Now I have a 1.00 grams of calcium chloride measured. I will transfer this in the second beaker and place my other weighing boat to the side. In my final weighing boat, I will measure out 1.00 grams of magnesium chloride. It is exactly 1.00 grams, and I will transfer it into my final beaker. And with that, all my measurements are complete. I will take a stirring rod and mix my solutes, which are 3 different chlorides, until they dissolve, or until I hope that they would dissolve. There are a couple ways in which we can ascertain solubility. The first is the production of a solution. A solution is going to be a clear liquid. So in this case, when we look at our water, on the bottom, we can no longer see any sodium chloride particles. And that means that all of it has dissolved. For sodium chloride, that means when it fully dissolved, it also separated into sodium ions and chloride ions that are surrounded by water molecules. So we should no longer have anything that we would call sodium chloride. Another way we can determine whether we do have a solution or not is to take a laser pointer, and this is through the testing using the Tyndall effect. If we have a homogeneous mixture, the Tyndall effect will not be observed. So when I pass a laser pointer through it, we may see a red dot at the entry and exit points, but no laser beam across the solution. And so that's what we see. 2 dots, one on the right and one on the left side of the beaker. So we have indeed made a sodium chloride solution. We can do the same thing with calcium chloride. Mix it in real well. First, we check for any visible signs of calcium chloride particles on the bottom. There are none. So now we check for the Tyndall effect. It is not observed in this case either. There is a red dot at the entrance and at the exit of the solution, but not a beam across it. So we made another solution. And finally, our magnesium chloride solution. We stir it well. The solution appears clear. There aren't any calcium chloride particles on the bottom, and we can check for the Tyndall effect, and we don't see the laser beam's path even in this case. We can conclude through these 3 experiments that most chlorides should be soluble because in our experience doing this experiment, the sodium, calcium, and magnesium chlorides are all soluble in water. If you were to expand this range of experiments, you can test your carbonates, your sulfates, and you can go beyond sodium, calcium, and magnesium to incorporate transition metals and essentially all the elements of the periodic table. When all these experiments are performed, then you may derive by yourself the solubility table of the ionic compounds of all the elements in the periodic table.